Okay, so I've grabbed a keyboard, PS2 keyboard, yeah, plugged into the back of there. Yeah, it's got onboard VGA, so we'll use that. Grabbed a USB mouse, we've got power plugged into it, so let's just switch it on, let's see what it does, yeah. So power on, power on, hit the start button, let's see what happens. It starts and makes a continuous long bleep and then starts again. Yeah, so power on, continuous beep, and then it kind of like stops, not exactly stops, the fan slows down, and then again continuous beeps. Yeah, so that's what it's actually doing. So I think now let's take this apart, let's get all the stuff out of it, because again, anything of this I sell the parts. Yeah, I don't really need the case, too heavy to ship on eBay. Okay, let's get it to bits and let's see what we can do with it. Okay, so there we have it, quite an attractive looking board. It's a 661GX-M7, yeah, 661GX-M7 revision 1.1. Was making a continuous bleeping noise. It comes with one dimming. There's stickers on this that's saying 12/2005, yeah. I noticed the hard drive. This is the hard drive that came with it, very dusty. Hitachi Deskstar, 80 gigabytes, 82.3 gigabytes. Also had a date code, I think was, yes, November 2005, yeah. Floppy drive, black front, and a IDE writer, yeah, LG multi-writer. So yeah, DVD, black fronted one with a big scratch down it. That's not of any value. None of these bits are really of any great value. I might get about €10 for the hard drive. Okay, so that's that. I think first thing we'll just do with this now. There's a lot of dust in this. I'm going to take the cooler off the CPU and let's have a look to see if there's actually any heatsink compound on this and which processor we have fitted. Well, on the front it said Celeron D, so I'm guessing that's what it is, yeah. I mean, it looks like nothing's been changed on this since it was new in 2005. This one. Often find with these old machines that all the heatsink compound's gone, yeah, it's just turned to dust or powdered or just literally just dry, yeah. Okay, so there we have it. Not as dirty as some, that's for sure. Let's take this off here. Yeah, it's a bit, there's a bit of gooiness left in there. It's not too bad, not the worst I've seen. What sort of processor do we have on this one? Let me just get the kitchen roll, yeah, a bit of kitchen roll. Let's have a look to see what we've got in this one. Okay, we can zoom down on that. So it is, in fact, and you can see the model number now quite clearly. It is a Celeron D. Celeron D, 2 gigahertz, or is it 2.8 gigahertz? Can't easily read it. Let me just get the magnifier right. Yeah. Celeron D 2.8 gigahertz. That's the CPU. As I say, it's not too dirty, so I think what we'll do is we'll just put our test heatsink on, the one we balance on the top. These capacitors don't look very clever. No, actually, they don't look very good at all. Yeah, can you see them? We have bad capacitors on this. Unusual to see this type of capacitor fail, to be quite honest, but they're like kind of like encrusted with some gunk, yeah, and they kind of look a bit knackered. Is the best way to put it. I think, yeah, before we even do anything else now, we need to take these capacitors off the board and let's have a look at them to see what condition they're in. I do think actually that's the first time I've ever seen this type of capacitors go like that. It looks like the value, by the way, is, well, 680 microfarad 4J, and there's 5.7 5.7 be a very strange voltage, so I don't think that's the voltage. Okay, let's start taking these out. So the easiest way with these I find is just to grab them, heat them from the other side with a blob of solder and remove them. I'll zoom out a little bit and we'll do that right now. So that the first ones are on this row here, yeah, and it's the two nearest this end that have visibly failed. So we'll get a good gob of solder. You've seen me do this before. If you have, you can just skip forwards a little bit. But basically a bit of flux. Get some leaded solder on the pins. This is a BC3 tip. It's a nice chunky tip, which is very good for getting a lot of heat into the board. Yeah. Try to get a blob of solder like that so it bridges right across the capacitor. I'm now going to grab hold of the capacitor with my fingers, and then I've realised I'm actually in the wrong place. The capacitor's here, not here. Okay, not a problem. Just clean this off. I mean, it's easy to do that, you know, when you're underneath. Sometimes you just hit the wrong place. The capacitor I want is actually down here. Yeah. Same thing again. Get some leaded solder, try and bridge the two pins together, like so, yeah. Now we can get hold of the capacitor with the fingers from underneath, heat the blob, and with a bit of luck it will come out before it gets too hot to hold. This is proving a bit troublesome. Let me get a bit of paper tissue, yeah, just hold it with that. Okay, I've got hold of it with that. Once again, let's come in here with the heat on both pins and see if we can get this one out. It's coming. I may end up having to take this metal bracket off actually. I suspect what's happening here is this metal bracket is actually like draining a lot of heat. Does it come off? Will it come off? Let's CPU out. Yeah, it looks like it's attached through here. Yeah, looks like it might come off. Just push out through the board. We'll have to unscrew something off it first. Let's see. See if these kind of unscrew or something. Oh, one moment. Okay, I've not seen this type before actually, but basically these pegs go through, yeah, and I've loosened these, but on them they have like a little white plastic ring, almost like a metal circlip, but it's made of plastic. And I have to just get something behind that and clip them off. Yeah, you can see that one there. So we have to take these off first, and then we can get this metal work off. I don't know how unusual these are, but that's the first time I've ever noticed them. Maybe I've had boards with them on before and just not really noticed. Yeah, a little bit tricky to get them off, but this is what we need to do. Okay, come on. Yeah, this one's been very temperamental. There we go. So that's how we take that off. Oh, there we are. Off. Now let's see if we can desolder these capacitors. I'll try again with the same method. So basically grab hold of the capacitor, heat the two pins, yeah, together, and let's see if they will now come out before they get too hot to actually hold, yeah. If not, I think we'll have to warm the thing up with some hot air and then go again. This one's, yeah, it's starting to come, but it's getting a bit warm. Well, that one, okay. Out it came, yeah. So that's the way we can do them. I'll just take the other ones out and then we'll have a look to see what we have here. Okay, so I've removed them. I removed all the ones off this row, both the electrolytic types that looked okay and the small ones, yeah, don't look okay, and for two reasons. One, because by removing these it made it much easier to remove these. That was a reason, that was the main one. It just made it easier to get to the other ones, but also they're all on the same voltage rail, so I thought I'd check them all out, yeah. So I removed them the same way I showed you the other one, blob of solder against the pins and just pull it out. Yeah, I had to use a cloth to hold the metal ones, they were getting too hot. Um, and then just hot air to warm the area, and the desoldering tool, the vacuum one, to clean the holes out. Yeah, this was quite a tricky one. I've shown these techniques on the how to recap video, yeah, and I'll link that on this one. If you're not familiar, if you didn't see the other video, you can see how I did this. Yeah, I will say this one was quite tricky. A lot of heavy ground planes and power planes in it, and I think I would have struggled to do this one without the vacuum tool. Yeah. Okay, so anyway, let's have a look to see what these capacitors are like. Let's give them a test. Okay, capacitance meter first then. These are rated 1000 microfarad 6.3. Yeah. Let's see. So black to the negative. Let's see what these read. Oops, you can't see the meter. That wouldn't help, would it? Let's see what these read. Yeah, that reads good. Quite a bit more than its rated value. Let's go for this one. Yeah, that looks good as well. Also looks good. Now let's look at these ones that look like they're bulbs. Can you see the top of that one? Looks like it's gone. Yeah. Negative will be the black. Yeah. The black side isn't going to be negative. So negative. What's this one reading? Well, it actually reads a bit more than its rated value. It looks like some sort of like something come out of these to me. So look at this one. That one reads bad. So that's reading below the rated value. Yeah. The ESR meter will really tell us. This one looks bad. Although it reads above its rated value. This one again looks like it's gone to me. Although it reads okay capacitance. And this is the last one, yeah. Again, reads okay on the capacitance meter. Let's get the ESR meter and see what that says. So here's the ESR meter. Switch it on. Just short the leads together and 0. Okay, close to 0. So have a look at the electrolytics first. I mean, I think these are okay, to be honest. I've seen better. Oh, you know, I've seen better. If I've got some replacements, I'll probably just replace these anyway, since I've taken them out of the board. So have a look at this one. About the same. Last one. I mean, the fact they're all reading about the same suggests to me that's, you know, correct for these. Yeah, about the same. Okay, what's those? So look at these ones, these little things. See what we got on these. That's bad. Another one. So even though the capacitance read okay, the ESR is bad. See? Bad. This is why the ESR meter is much more useful. I mean, they're both useful, yeah, but this is why you need an ESR meter. Look at that. 9. Okay. And remember that the capacitance read okay. I mean, okay, we can see it visibly not good, but even so, this is showing the usefulness of having the ESR meter, yeah. If you haven't got one, put it on your list, okay. Get yourself a good one. Yeah, that one was sort of okay. That's the one that hasn't got, it's bulbs but it hasn't got the brown grunge on. Okay, so we've got some bad capacitors there. Let's have a look and see what I've got to replace these with. Okay, so I had a look. I've got some the 1000 6.3. It's a value I keep in stock because they're quite a common and useful one. So those we can replace. Let's have a quick look at these replacement ones. I mean, the other ones are the SR of about 0.3 or 0.4. And in fairness, they tested okay. But I think, well, as soon as I've got them off, I may as well change them, yeah. Yes, that's better, 0.213. So they're a bit lower ESR than the ones that I took off the board. So we'll use these for that. So this one. So these are a little bit better than the old ones. So these we can put on. The others, I have some that are slightly lower value, but I think we can get away with it. So yeah, I'm happy with those. That's replacements for those. The other ones, I don't have any 680s, 6.3s, but I have some 560 6.3s. What I'm thinking with these, let's have a look at the SR one or two of these. I mean, bear in mind other ones were reading 4 or even 7 ohms, yeah. So let's have a couple of these, just out of interest. Negatives are short lead, positive on the long one. What we got? You see, much better, yeah. These are good capacitors. What I'm thinking with this is, if you can see, these are alternating between the 680s and the 1000s. So we'll put the 560s in there. I don't think it's a problem. These are 560s, yeah. But and the originals were 680s. But if you look, there's a couple more spaces here for capacitors that weren't fitted. And if we get the multimeter and we just check, we'll probably find that these are, effectively on the same voltage rail, yeah. So this end is negative, and they will connected together, yeah. And then the positive, I think we'll go to these, yeah. Positive. In fact, there's some more down this side as well. Yeah, they're all on the same. Well, I think if we put 2 more in here, so because we're using 560s instead of the 680s, we'll replace these. We'll put a couple more in here as well. That'll make up easily for the loss in capacitance, yeah. And then I think we can try it. So I'll just clean the holes on these, and then we'll solder the others into place, yeah. And I'll just show you actually this time how I'm actually doing this. So these are the 2 that I need to unsolder. Or rather, not unsolder. I need to clean the holes in the board, yeah. And the way I'm doing this is I'm just taking a little bit of flux, yeah, onto the board, and some leaded solder. So adding leaded solder will reduce the melting temperature effectively. It amalgamates with the existing lead-free solder, so it forms an alloy and effectively reduces the melting point. So we get some leaded solder on those, yeah. And then I'm taking the hot air, warming the area of the board. Hot air set to 450, yeah. I'm just getting some heat around here. And this is my desoldering tool, yeah. So once I've got some heat, putting the desoldering tool on, heating it up. And I didn't quite do it long enough, so it didn't clear that one. Let's go for this one. Now it's going. That one didn't. That one did. So the 2 that didn't desolder, we'll just add a bit more fresh leaded solder and we'll come back on those, yeah. And we'll just give it a little bit more warmth this time. So that's one there. And one here, yeah. Again, hot air. The desoldering gun is set to 385 centigrade. This is on 450, maximum airflow. Give it a good warm this time, yeah. And that's cleared the hole, I think it did. And that one. I'll just double check. That one's certainly clear now. Just this one. Yeah, that's got them, yeah. I honestly think on this particular board you could see that was taking quite a lot of heat to do that, yeah. So I think really this is where you do need the tools to do the job properly. Just clear that, yeah. Always do that before you switch this off, and then it'll stop it clogging up, yeah. Okay, so we now have all the holes free, so it's just a matter of soldering the capacitors back into place. So I've replaced all the capacitors. It looks quite nice now. I've put the CPU back in. We'll put a bit of heatsink compound on this, and then I'll just balance my test heatsink on it for now. Well, we can just see what this does. So this is just the heatsink I use. The legs on here are actually too short to touch the board, so I can just balance this on top of the processor. It's not going to short anything out, yeah, and it's sticking to it well with the compound, so I know it's actually making contact with it. Actually, this might actually screw on this. No, it doesn't. Oh yes, it does. It actually fits this. I've always wondered what this came off. Okay, so we'll put the heatsink on in this case, screw it down, see as it fits, and then let's give this a go and see what happens. Okay, so we're ready to go. I'll just check the CMOS battery before we fire it up this time. See if this is flat. Let's have a quick look. Yeah, so the CMOS battery is dead. So we may as well change that while we're here. Probably this thing's been sitting around for years, yeah. Let's just find another battery. Okay, I've put a new battery. See what we have now. Yeah. Okay, so that's a good battery now. Let's just give this one a go, I think. Power button, it's got a speaker on the thing, so I don't need to plug a little speaker into it. We can switch some power on. And we have the same, like a long continuous bleep, yeah. Post analyzer card is just saying 0. Okay, let's take this RAM out of it. Actually, that's really stiff to get out of there. Let's try it without any RAM and see if it does the same thing. Yeah. So the thing is, basically it's saying it can't access the RAM, yeah? Okay. What is this? PC3200. Yeah, oh, it's like DDR4. Let me grab some memory. Okay, so I have a handful of DDR4 memory here, basically. Yeah, all different sorts of sizes. The 256 512s or ones, basically 1 gigs. Yeah. Let's try this one. The 256. Yeah. 256. So this is the same capacity as the one that came out, basically. Try that one. Ah, 1 beep. Postcard still on 0, not actually doing anything. And oh, then 2 beeps. I don't have a picture though. So like 1 beep and then 2 beeps and no picture. That's interesting. Yes, it seems like this post analyzer card has now started to work. That's strange that I plugged the other one in, it was working, then I plugged this one in, it works again. I don't know what's going on, maybe it's had a bad connection. Maybe we've just got some bad connection in the sockets on this, you know. Yeah, and then bleep bleep 7F. According to my little book, that says 7F. Extended non-maskable interrupt source enabling is in progress. Okay. I'm just going to try and just reset this RAM a few times. Yeah, I think maybe we've just got like some guns in the sockets on this. That says it's okay. Same error. I'm not sure exactly what that one means, to be truthful. Let's see if is this RAM slot working. Sometimes it seems to switch on as well. When you switch the power on, it just switches on by itself, yeah, rather than me pressing the button. Same. Button and switch off. Switch on. Same. I'll try a couple of the sticks of RAM, see if I can find one that wants to work. Otherwise, we'll have to have a look to see what we can figure out with this one. Okay, I've tried a couple different strips of RAM in both sockets. It makes no difference. Still, when I power on, it tends to power on by itself. That's the first thing, yeah. Back and powers on manually. And we get into this 7F. Next one. Yeah, 2 bleeps. So it obviously doesn't like something. Let's just check obvious things. CPU socket would be the next one. We'll just see if there's any dust or dirt in the sockets, I think. Well, it looked okay before. I'm just going to magnify on this. I think I can see yeah, I can see a bent or broken pin in this. Let's get it under the microscope and we'll have a look to see what we've got. Yeah, it's here, guys. It's just down this edge of the socket. If we have a look, you can see it's just there. Yeah, this is a bent or is it broken? Let me get the tweezers and let's have a look to see. Find some tweezers. Let's have a look to see what we've got here. Oh, this is a broken one. I can see there's like effectively the end of the pin's missing. Yeah. That's not looking very clever. Can we? I can try and bend it up a little bit to see if I can get it to contact the CPU. That's one thing we can do. We can also have a look on the internet and find the pinout for this socket 775 and look to see if this pin is like just a voltage pin or a ground. Because I mean, with these processors, you have like lots and lots of pins that effectively, you know, the voltage or the ground. So if you've got one bent or broken, it's not really a problem because there's many more pins. But yeah, you can see I've pushed that up as best I can. It's might make a contact, but yeah, that could well be the cause of our problems, I think, with this board. Okay, we'll put the processor back in and let's see if it has the same problem. If so, let's see if we can find out what that pin actually is. Yeah, okay. Okay, I've got it back together again. Let's try again. Power it up. Let's connect the wires first and then let's try again. Power it up. That's not going to help, is it? Okay, let's plug everything in. Yeah. Now let's power it up. Get it. See if we have the same problem. Yeah, exactly the same. Okay, I think what we'll do now is let's have a look at this pin in the CPU socket that is broken, and let's have a look to see what that pin actually is. Yeah, is it an essential one basically? Okay, I'll take this back off and I'll have a look. Okay, that's a bit inconclusive really. I found the data sheet for the processors, the P4s, yeah, and it was fairly easy to identify because you can see where the missing pin is in one corner and then two, yeah. And the one that we have broken is basically the second row up from this side of the big hole in the middle of the socket. And it's this pin here, TMS. That's the one that's actually broken. It doesn't have a hash after it, so you assume that's an active high signal, yeah? It's like a voltage on it. No, sorry, it would have a voltage on to activate it, yeah? So if it was high, it's active. Looking to see what that actually was, TMS, I had to scroll down quite a way down here to find out, you know, what all these signals actually are. And if we just get a bit further down, it will actually tell us what these signals mean, and we'll find this TMS signal. Just one moment and I'll find it for you. Maybe a little bit further than this yet. It's a big data sheet, yeah. Here we go. So this explains what all the pins are. TMS says it's a test mode select for JTAG specification support signal used by debug tools, which would suggest that generally really this pin isn't important, but I'm only guessing that because it's broken off it's kind of like floating maybe, and maybe it is kind of activating. Possibly that's why it's asking for this non-maskable interrupt thing, I don't know. Maybe that's something put into debug mode. So I'd say the first thing we really need to do with this is to figure out if we can actually repair the broken pin in the socket. Before we go any further, there's no point, you know, chasing other things until we effectively solve this problem. Yeah, I think you'd agree with that. So, can we do this? Well, I've not tried it before, but I have heard of people, especially one guy on badcaps.net, who actually managed to like unsolder the broken pin and solder in a pin from another socket, a donor, yeah. So I'm going to have a look at that and let's see if we can actually do it. I think I have a donor socket somewhere, so first of all we can try and get a pin out of it. So this is a donor board. It is a socket 775. It's a gigabyte board that needs a special SLI adapter to make it work, basically, even if you want to use it in non-SLI mode. It's got no onboard video, and you put a video card in, it won't detect it because this is missing. And I tried to get one, I couldn't get one. And to be quite honest, it's not worth it for the board of this age. It's nothing very interesting anyway. So I've used it already to take off a Super IO here for one job we were looking at. So I'm thinking we can use this to get pins out of the socket. But what I want to try first, see if this will work. I'm going to see whether I can actually like effectively cut the end off one of these pins and solder it to the broken one. Not tried this before either, yeah. And the reason I want to try that, not as a permanent fix, but I want to see if I can get a connection on that pin in the CPU to connect from the socket to the CPU, yeah. And if I know I've got a connection, then I'm interested to see if we've got the same fault, because it occurs to me that this thing probably had a bent pin from all the time, you know, before that processor has obviously been there a long time, and I assume it was working probably until the capacitors gave up. There's also a very nice set of capacitors on this board as well, actually, so it's even got the values that I wanted for that one. This will make a very nice donor anyway. So let's get under the microscope and see if we can actually possibly use part of one of these pins and solder to the other one as a temporary fix to see if we can actually make a contact to the processor. Okay, let's go to the microscope. So this is the socket. I was thinking actually of trying to effectively cut the end off one of these and solder it. But while we're at it here, I want to try to see if we can actually remove any pins out of here. So I've read, a guy on Badcaps was posting about this, that basically what he did is he got a lot of flux in here, yeah, and he used the hot air to heat the area up, and literally with a pair of tweezers he could pull the pins out, yeah. So we can give that a go. I say this is all very new to me. I could do with just raising this up off something first, so it's not sitting directly on the desk, so I can get the heat into it a little bit better. Okay, I can't actually do it under the microscope because I've got it up onto a metal sort of lid off an old satellite receiver. Yeah, so it's not sitting flat on the desk, taking heat out of it. And when it's on here, I can't actually get enough space, enough gap under the microscope. Yeah. Oops. Problem with my camera. One moment. I can see a lot of crazy like horizontal lines flashing on the picture. So hopefully you've got a good picture now. Let's first of all let's just warm this up, yeah. And I'm assuming that flux is going to kind of like disappear down inside the socket, yeah. I may have to use the magnifier a little bit. I'll try without first, so you guys can see what I'm actually trying to do here, yeah. So effectively now I'm going to warm this up and see if I can pull any of these pins out of the socket once I've got some heat into it, yeah. I'm not sure how well this is going to go, if it's going to melt the socket. Having this metal frame probably isn't going to help either. But it's a donor board, so I'm not too worried about it. The socket's melting, so I'll take the heat a little bit further away. Let's try and get some heat into the job. Now, can I get any of these pins out? Yeah, I can't. Taking the pin out of it. Okay, I'm not sure where the pin's gone, but it definitely came out. Oh, no, it partially came out. Now I've got pins coming out of it. So I get another one, yeah, so I get two of them. You see where I take one out from there? Okay, I've got a couple of pins out of that. Let's have a look to see what we've got. Okay, so I've got a couple of pins out of this. So let's have a look to see what we've got. These are the pins. So that one's a bit more bent than this one, I think. Let's turn this one over onto each side. Probably be better with two pairs of tweezers. There we go. Yeah, so it looks like it has like a long bit that goes inside the socket, a flat bit that solders to the board. Yeah, and then this pin is bends over. Yeah, at the top. So if I just try and keep this a little bit straight. Yeah, this is your flexi pin. Yeah, your bendy pin. So let's get the other board. I wonder if it's kind of possible to kind of like push this in over the other pin or something like that. I think I could probably remove pins from the other board, but I think we'd have to use a heater from underneath so as not to melt the socket. But let's see if we can do anything just to like kind of codge this in there for now, yeah? Okay, so this is our broken pin, and this is one of the pins I actually managed to remove from the other socket. It looks like, yeah, the back part of this pin is kind of like flat here in the hole. I think the way to have a go at this, I was going to try and solder something onto this, but I mean, you can see I'm making this up as I go along here, guys. I'm thinking now if I bend this one up a little bit, yeah, I can probably heat this board from underneath, so I have to use the preheater underneath it, and pull this broken pin out and shove this new one down the socket and try and solder it with a bit of leaded solder on the end of it. I think that might be the way. So yeah, we'll have to get it onto the preheater and see whether or not we can actually get enough heat into this from below to do that. So I think heating it from above, I'm just going to melt the socket. I mean, I've just seen what happened on the other one, yeah, so that's fairly obvious. That's what will happen if we do it from the top. Let's try it from the bottom. Who knows? One way to find out, guys. Okay, so what you can see I've done is here, I've just used my tweezers to get a little bit of flux on the end of the tweezers and get it down the hole for the broken pin, yeah? I'm now going to put this on the preheater and see if I can actually melt the solder from underneath. If I can get enough heat into it, I think I probably can, and should with a bit of luck be able to get this pin out of the socket. But as I say, I've not tried this before, so you know, it's all new. Anyway, we can give it a go and let's see what happens. So I'll just remove the CMOS battery. I mean, it's not that close to where we're going to be working, but I think it's probably a good idea just to take it off the board. Don't want this thing exploding, yeah. On the plus side, if you look underneath the board, this is where the processor is, yeah. There's no components on the back of the board, so that's in our favour, yeah, the fact that there's no components on that side of the board. So let's get us on the preheater. I'll put a temperature probe near to the socket and let's see what happens. Okay, so I have the thermocouple balanced as best I can on the board, yeah, so it's touching it, yeah. I've got the board balanced as best I can on the thing so it won't fall off. And now we can start to apply some heat to this to see whether I can actually get this thing hot enough to desolder. Okay, temperature's climbing. I'll pause the video and we'll be back when it's getting hot. Okay, you can see I'm getting quite a bit of heat into this now. I'm going to turn the heat up towards maximum now. In fact, set it to maximum and see if I can actually get enough heat into this from behind the board to actually melt the solder. I think it's going to be touch and go, to be quite honest, if this preheater will actually manage to do this, yeah. And possibly just try wedging something under the board. I'm just trying to raise the board off the heater a little bit so it's not conducting heat back into the metal plate effectively, yeah. Try that. Maybe, yeah, it's just a bit of cloth or something. I think let's just see if this helps, if I can get a bit more heat into this. Effectively, I've raised the board away from the metal frame of the preheater, yeah. And still, even on maximum setting, it doesn't look like I'm getting enough heat into this. Let me see if the thing's actually coming loose at all. No. No, all that's happened is I've actually broken the connector off further down now, so I can't pull it out. So that didn't help, so we'll switch this off and see if we can find another way to do it. Okay, so that wasn't exactly successful, was it? In fact, I think it's just made matters a bit worse, to be quite honest. So what we got now? Well, the interesting thing, anyway, for start off, is it's like the flux is kind of like attacked the plastic. Obviously, I haven't got it hot enough to melt, and I don't see any reason why the flux would actually transfer more heat into the plastic here, but it's kind of like attacked it. Just inside here, if I just zoom down a little bit, I'll use the microscope as well so I can see myself. So, just inside here is like the bent pin. Let me get a little bit closer, and this is kind of like flux effectively stuck in it as well. Let's go down here. Okay. So, can you see in here? I'll try to do this without looking down the microscope so you get the focus, yeah. That there effectively is the bent pin, see it there? That's what's left of it, it's snapped off. So we need a plan B or a plan C. What I'm thinking now is to take one of the original pins and effectively like try to cut off the back part and leave enough of it, the pieces goes back down inside, to wedge inside here between there, yeah, where you see that flux coming out, and then possibly try and solder it onto it. So again, I have no idea how this is going to pan out, but you know, we don't have a lot of other options here now, so let's give it a go. Let's see if that gets us anywhere. Okay, so here's our replacement pin, and I'm thinking if I can try and cut the top part off this, just before where it's sort of like you can see you've got a little wide flange at the top, and this is like in two halves basically, it's like a stringy part of it here, yeah. And I think I'm going to try and cut this off, sort of where the two join together, or just below it, see if I can wedge that inside the piece that's still in the socket. We've got plenty of pins in that donor board. We can still get some more pins if we mess this up. So let's let me give it a go and see what happens. Okay, so I've got part of the pin. Yeah, this is the top half of that pin that we had, and I'm going to see whether I can wedge this down into the slot basically. Yeah, I have no idea. It's very small and rather fiddly to get hold of, but let's see if I can actually get an angle on it. I probably need two pairs of tweezers for this actually. Yeah, thing doesn't even want to stay still. Let me just get another pair of tweezers. Okay, got a second pair of tweezers. It's not as fine as these, but hopefully this will help a little bit. Yeah, actually they might be easier to hold than these ones, being a little bit thicker. Need to figure out, so that there's like a little bump here that needs to point upwards. Yeah, lost it now. Let's see if I can fiddle this around and get it down into the hole to wedge it in here, yeah. I mean, if not, I've cut it too short, you know. We can try a few more. We've got a few more. We got lots more attempts at this, yeah. We've got lots more pins we can actually use. Let's see if it's actually possible to do. I guess I need to come in kind of like vertical. Twist it round. Yeah. There. I think I've got it, guys. I think I've got it. Problem is now, can we solder that in place without it falling out? Yeah. Then once we get it in place, we can effectively bend it where we want it to go. Well, all we can do now is try. I've just adjusted the focus there for you a little bit so you can actually maybe see what I've done here, which is to wedge that piece down between the other two bits of springy metal, yeah? Okay, we need to get a fine tip on the soldering iron now and see if we can actually get that thing to solder. Okay, I'm not too worried about the fact that that pin is kind of like bent over one side, yeah? I'm sure if I can get this thing to solder, I can bend it to where I want it to go. That's not worrying me too much. I'm more concerned about getting in here with a soldering iron tip. This one is the ILS tip, yeah, T12 ILS. This is probably the finest tip I have. And I'm going to try and probably rotate this board like so. Get back into shot for you, yeah, and try and come in from this angle. Whether I will be able to solder it or whether the thing will just stick to the end of the iron and come away with it, I honestly don't know. As this is a new territory for me, this one. Okay, let me I probably need to zoom that out actually a little bit for me to work on it. You sometimes find on very high magnification you can't actually work. Yeah, you need a little bit lower. Let's try that. Let's see if I can actually get in here with a tip and a little bit of solder and actually solder this thing. No, it's done exactly what I thought it would do. It's stuck to the iron. Okay. Well, I think the principle's good. It's just the thing's effectively just stuck to the iron, yeah. Is this thing pushed back again and stuck against there? Yeah. I'll probably now struggle. Yeah, because what I've managed to do is now get this thing full of solder. I'm going to have something of a job. I wonder if I can actually push that, or the other one. Let me find the other one that I removed and see if I can shove that into it. Okay, let's have another attempt. So what I've done now, I've actually cut the pin a little bit longer, yeah? So there's a little bit more of it on there. Can you see it there? There's the pin, yeah? So it's now longer. I need to look down the microscope to be able to do this. So there's the pin. And I want to see whether I can actually effectively shove this down this hole and solder it to the other one. Let's have a look, see if it's possible to do it. Well, I can get it down the hole. Whether or not it was short against that pin, I don't know. We can get it down the hole, but we can't get it far enough back to help. So that's probably not going to help. I can't bend this far enough over from there, I don't think, to actually do it. Let's see if we can push this back here. That might do, you know, and if we bend this bit over this way, we can give it a try. I mean, no harm in trying, as they say. Let's see if we can solder that into position there and then bend the rest of it over far enough to make a contact. Look a bit messy, but it might work. Okay, making the centre of the thing. Let's see now if we can actually solder this. Okay, come back again, so let's have a go with this. Probably need a little bit of flux in there as well to have any possibility of doing this whatsoever. Aye, find some flux. Which I'll try and apply a bit using the tweezers again, so I don't get too much flux in it yet. That's too much flux. A bit of kitchen roll. Let's see if we can remove some of that. Yeah, that's got a fair bit of it off. Of course, a bit of kitchen roll stuck to the pin now, but we can soon deal with that. So there's the pin. Yeah, I'm sure we can bend this into place if we can just get it to solder. So there's our repaired, attempted repaired pin. I can just zoom in on that. There we go. Get into focus. Just check the focus on the screen for you as well, because my focus is slightly different to yours. Okay, so we can see this is the pin. I mean, it pushes back. Whether it's just loose or whether it's fixed onto that, I don't know. I can't totally decide I think it might just be wedged down there, you know, not actually making the contact. But when I try to pull it out, it doesn't seem to want to come out. Yeah, it seems to be attached in there, so I can't lift it out. It's not coming out easily. I've got a bit of solder on this one and this one, but that's not really going to cause a problem, I don't think. The pin's pretty much in place. I mean, I've bent it over a little bit to get it roughly where I want it to go. It's a little bit forwards, but I think we can hopefully live with that. So let's put the processor back in on this board and let's see if that actually makes any difference now. Okay, so we're ready to try really. Switch the power on. Again, it's powered on its own. It seems to do that for some reason. That's different. Oh, I've got a picture. I have a picture on the screen. Let's get a keyboard. Okay, so yeah. I can't quite believe that. But yeah, we have a picture. There you are. See, it's booting up. Let's see if we can get into the BIOS. F12 it said. Dell to enter BIOS. Yeah, we're in the BIOS. Right. I'm sorry, but that was just that's mad. I honestly did not believe for 1 minute that was actually going to work. And there we are. We've got a oh my god. Okay, I'm going to stick the original hard drive on it and see if it'll actually boot. Okay, I've put the hard drive on, so let's see what happens now. Maybe I have to go into the BIOS and just tell it to load the defaults. Might be a good idea. Yeah. Has it seen the hard drive? Yeah. I've put it onto the SATA. It says it's a channel 2 master, so the hard drive's there. Load default settings. Yeah. Save. Yeah. Let's see what it does. I mean, you'd think these would come with wiped hard drives. It may well do. I mean, I can't say for certain this is a bootable driver. Oh, there we go. There we go. So, yeah, Windows XP. I don't have a mouse attached at the moment. I'll soon go and grab one. Here we go. I'm guessing the CMOS, like the date and timer out, because that's replaced the battery. It's probably been flat for a very long time. Well, that's just loading. Let me get myself a mouse and see if I can get in here. Okay, I grabbed a hard drive. Sorry, I grabbed a mouse, which doesn't seem to be... Oh, it's found a mouse. That'll help. It's just saying in the corner it's found a mouse. Interface of human USB. I'm not sure this mouse is actually a good one. It might be a bad one. Just saying about some errors on the computer. Software errors. No, looks like this mouse doesn't work. Let me go. Oh, yes, it does. It moved then. It moved. Maybe find something to yeah. The mouse is moving. Yeah, it's just a dodgy mouse. There you are. You can see the pointer's moving around the screen. Yeah. Oh, it's going now. It's working. Okay. So there we go. Obviously, I need to format this one. Can we just see the specification of the computer? Properties. Get rid of that. There we go. There we go. Got another no, that's not the registration key. Service pack 3. 2.8 gig Celeron, as you can see, which is what we have in it. The 1 gig of RAM, I imagine it says somewhere. Yes, there. I put 1 gig of RAM in. Okay, so this one is declared fixed, guys. And that was mad. That was just crazy. Well, I've got to say, I mean, that one, it was against all my expectations, and I've got a buzz, guys. I've got a buzz from that. It's like, you know, I've got this problem with a broken pin in a socket, and I probably do like the craziest thing I can think of to do to fix it, and I fix it. And that's what this is all about. It's things like that. I'm telling you, I'm going to be on a high all day after that one. I really hope you enjoyed this video. You know, it's one of the most amazing I've ever made, in my opinion. So yeah, I hope you enjoyed that. That's for myself. Thumbs up, pat on the back. See you soon, guys. Ciao now.